We're looking at problem number 4, and if you can see, I already started underlining all my numbers. So I have a 300-gram sample, which is my mass of steam gas at 100 degrees Celsius, which is a temperature, is condensed completely and cooled to 20 degrees Celsius, my other temperature. How much energy is released? So I'm solving for Q. So first thing, I'm going to draw my graph, and I'm going to put my two temperatures on it. So I have 20 degrees Celsius, and it's going to 100 degrees Celsius. Okay, I am doing a water problem, so I need to see if the melting point and boiling point of water fall in between these two temperatures. So if it's going to go through a phase change at all, and 0 degrees can't fit in here, and 100 degrees Celsius, the boiling point is already here. So since it is going through a change process, I'm going to draw that line. And now I need to see, is it heating or is it cooling? Because that's going to tell me if I draw an upward line or a downward line to 20 degrees Celsius. And it's telling me that it's getting cooled, so it's a downward line here. Now what this is telling me is that this is going to be an exothermic reaction. So if it's losing heat, my answer is going to end up being negative. And if we're marking this, it's boiling, so this is going to be letter D, and this will be when it's a liquid, so it's letter C. So now let's go through the math of this. So let's do part D first. So D is when it's going through condensation, so Q equals HV times N. So HV, if you look at the top, is 40.7 kilojoules per mole times N, which is my number of moles. So I need to figure out my number of moles. So I'm going to do 300 grams of water over 1 times 18 grams of water over 1 mole. And what that's going to give me is 16.67 moles. Okay, my units are going to cancel out. I'll be left with kilojoules, and I'll be left with 678.47 kilojoules. Now, as I mentioned before, this is an exothermic reaction. So this is a release of energy at this point, and so it's negative. Okay, had this been endothermic and heating, we would have kept it positive. C is Q, because we're looking at a liquid phase now, is M times specific heat of a liquid times a change in temperature at a liquid state. So our mass given in the problem is 300 grams times our specific heat liquid, which is up at the top, 4.187 joules per gram degrees Celsius, and our change in temperature, so be careful here, our final is 20. And our initial is 100, because it went from 100 to 20. So 20 minus 100 is going to be negative 80 degrees Celsius. Okay? And so that negative is already going to make our answer here negative. So our answer is 100,488 joules, but I would need it in kilojoules. I'm going to move that decimal over, and this is going to give me 100.49 kilojoules. It's a negative in both instances. Okay. I'm going to take my two Q's, I'm going to add them together to get my Q total, which is negative 678.47 kilojoules plus my negative 100.49 kilojoules. If I add those together, I'm going to get negative 778.96 kilojoules. And here is my negative answer. And you'll notice that this is much higher than the last video I did, and what you're going to find is when you have a higher gram amount, you're going to need more energy. So the more mass there is, the more energy it's going to take for it to transition. Okay, you can think about that the same way if you're boiling a pot of water. If you're boiling just like a small amount of water, it's not going to take as long for it to boil as if you were doing a huge pot of water. That would take a really long time to boil because you need so much more energy. So these higher numbers, make sure they make sense with your mass.